first of 3 videos for topic 2, sequences of rigid motions in a coordinate plane. So let me start with what we're trying to get done today. The learning targets is we want to be able to describe a sequence of transformations. Now the word sequence means we're going to have more than one, multiple transformations that would map a pre-image onto image. And what this says is you want a sequence, meaning there are many right answers that could be acceptable to describe how a pre-image would end up onto an image. But your goal is to figure out just one of those correct ways to do that. And then what we're going to talk about is because rigid motions produce congruent figures, we should be able to write a list of corresponding parts, sides, and angles of triangles that are congruent as a result of the rigid motion. So explaining why triangles are congruent because of rigid motions, and then also writing a list of corresponding parts. Now, parts of triangles, again, are sides and angles that have to be congruent as a result of the rigid motion. Now, let me talk about strategy first, and then I'll come back with a new video about each type of question. So here's my lesson strategy. Is same thing goes for topic 1 as in topic 2. The first thing is you always want to determine what is the pre-image and what is the image. Again, the pre-image is the figure before any transformation occurred, and this is the one that we need to move. So first step is always decide which one is the pre-image and which one is the image. Then you check your orientation of both figures, because in this case, it won't be just one transformation that will map the pre-image onto the image. It would be 2 or more. And so what we want to do is check the orientation, because this is basically going to tell me which scenario, which case I'm going to go with. If the orientations are the same, then we could likely describe our sequence using a rotation and a translation. If the orientation is different, then our sequence is likely a line reflection and a translation. But in either case, I think it's always best to use a translation first to map a point of the pre-image onto its corresponding point in the image, and then we can either reflect or rotate, because both of these types of movements require you to do a translation, and then it's either a line reflection to change the orientation, or it's a rotation to finish the mapping. Now, you don't have to do the translation first. I just think it's easiest to do a translation first. And I'll show you how I do that. And then when you're asked to explain why rigid motions produce congruent figures, so if you say, how do I explain why rigid motions are producing congruent figures? Use one of the following sentences to explain. Literally just cut and paste. Because it's going to be one of these 2 scenarios, or if it's just one of the rigid motions, you can just cut one of these words out. But either a translation and a reflection happened, and we can say translations and reflections are rigid motions because they maintain size or the distance and shape or angle measure. So that is the explanation as to why those 2 rigid motions produce congruent figures. Or if it's a translation and a rotation, are rigid motions because they also maintain distance and angle measure. Okay, so there's a little preview as to what's to come, and I'm going to make one video for each type. So look for that now.